Hi guys, we are going to see now changing magnetic field inducing EMF in stationary coil. Now this is the bar magnet which would be moving in the coil this way and that ways in simple harmonic motion, or rather in form of oscillation, and owing to which the lines of force would be cut by this coil. So coil would be stable but magnet would be moving. So it would be about changing magnetic field. Changing magnetic field, why? Because the magnet is moving. So magnetic field is changing and the coil is stationary. Earlier what we had seen was motional EMF in rotating bar. Now this was rotating rod. The rod was rotating, but the magnetic field which was there, that was stable. So magnetic field was stable and the rod was rotating, owing to which there was EMF generated in this rod. But now what we would see is this flux, magnetic flux, is being cut by stationary coil, and in stationary coil EMF is generated. Alright, so that's the difference between that and this. Quite interesting. Okay, let's check it out how it works. This is a semicircular arc on which is fixed a bar magnet, permanent magnet. It would be swinging this way. It would be swinging this way. Alright. Now when it is swinging this way, what is going to happen? Obviously the magnet would be passing in through it and then again coming out through it, passing in through it and coming out through it. Alright, this way there would be an oscillatory motion going on. Alright, now this obviously is the mean position, and whatever angle the magnet covers, that would be theta. Alright, so suppose if it moves in here, so angle is theta, comes to mean position, moves in here, again it is theta, then again moves in here, so that ways. So this becomes the mean position. So at mean position, theta is equal to 0. Now this is the situation that is happening. Now, what are all this? So this coil which is there, it has say 10,000 turns. It's a copper wire loop of 10,000 turns. We want to generate good EMF, right? So it has got 10,000 turns. This is then connected to a resistance and a diode, and then comes a key, diode, and then comes a key. Alright, and then this is voltmeter, and in parallel is connected capacitor. We know that voltmeter always has got to be connected in parallel with capacitor, and to measure current we have got a milliammeter over here. Alright, so what's the mission of all this process? The mission of all this process is to charge the capacitor. Alright, and another thing that we have got to know is there's something called as forward biased and something called as reversed biased. Now we know whenever forward biased is there in case of semiconductor, the current flows in. Whenever it is reversed biased, current does not flow in. And when is it forward biased? When the positive terminal is connected to positive of a diode. Alright, at that time it becomes a forward biased system. This obviously you are aware is positive P junction, and this is N junction. So P junction, N junction is positive terminal when is connected to P junction of a diode, then it is forward bias. Alright, so that's what we have studied in semiconductor. Alright, now with this all information, let's proceed towards the process. Now let's see what happens actually. So as I told you, it's swinging the magnet which is there. Assume the magnet is over here and then it is moving in like this and then again going back like that. So it's keeping on happening that ways. So what is happening when it is entering the coil? As per Lenz's law, when the lines of force or the flux is being cut, whenever there is change in flux, EMF is generated. And yet another thing we know, that EMF generated is also depending on rate of change of flux, d phi by dt. And we also know that d phi by, as per Lenz's law, we also know that d phi by dt gives you negative EMF. Alright, so that with these informations, let's get into it. Now, so when bar magnet enters into it, so EMF is generated. Why? As it is entering, its lines of force are being cut. So EMF is being generated. So, but what EMF? It is negative EMF. So that's what we see. Now at time t1, this is what is happening. So at time t1, what we find is negative EMF is being generated. Now I again want to bring to your notice that E0, I0, these represents maximum EMF and maximum current. So at T1 it's being cut, so what we end up with is EMF but in negative direction. Alright, and then again at T2 when it is leaving, so see, when it is entering, it is leaving. So when it comes here again at time T2, what's happening is, now it's a reverse of the process. Now here at that time it was being cut, and here at that time it is receding. Alright, so when it is receding, now positive EMF is generated. So at time t1 while entering, it is negative EMF which is generating, and at time t2 this magnet is quitting the coil. While it is quitting the coil, reverse is the process of that. Since it is reverse the process of that, so it is positive EMF which is being generated. So while it was entering, it was negative EMF which was generated, and while it is coming out of the coil, it is positive EMF which is generated. And you know, forward biased is when positive is with positive. So it's while positive EMF, diode is forward biased, whereas when it was negative at that time, so negative to positive, so it was reverse bias. So capacitor would be charged only when this part is involved. Alright, so for every cycle, so we know whenever we are talking in terms of a cycle, it would be, this would complete one cycle. So when it is completing one cycle, so in that cycle, it's only the positive EMF which is going to charge the capacitor. Alright, so we know N phi, we have got 10,000 turns, so becomes equivalent to 10,000 times. So EMF generated is really high. So EMF generated positive or negative is also very high. Alright, and then we also know it depends upon, EMF generated also depends upon the rate at which it is moving. So if we move it faster, then EMF generated also would be more. So EMF would depend purely on flux, and it would also depend upon it would also depend inversely upon time period. What shorter the time period means, it would be moving in faster. Alright, so we would see that that's the formula that we are going to derive, where we would ultimately conclude saying that it depends on flux. So it depends on more number of turns, more flux. So it depends on flux, and it also depends inversely. So it's directly proportional to flux. N phi, so N is 10,000 turns, so flux is 10,000 times that of only one coil. So it depends on flux, and it is inversely proportional to time. So it's directly proportional to flux, and it is inversely proportional to time period. So time period, why inversely proportional? Shorter the time period means it's moving faster. Alright, rate is very fast. So rate is very fast, EMF generated also would be pretty high. Alright, so as a result of that, the capacitor also would be charged more. Alright, okay, so that's what is it. Now so we understood this graph. Now let's try and understand this graph. Now what happens is when it is entering, we saw this, that it generated EMF. At T1 it generated EMF. So this is the growth phase, and at this time the bar magnet is entering the coil, and since it is entering the coil, it has got to get opposing EMF, so it gets minus EMF. But right now we are talking only in terms of flux, so flux is being cut, so maximum change in flux while it is entering, so flux is increasing. Okay, now when we come over here, it has already, the magnet is already into the coil, so at that time there is no change in flux. Whatever is the change in flux remains constant, so magnetic coil is inside. Maximum but constant, maximum but constant. All right, now again when we come over here, again it is decay. Now it is decay. When it is coming out like this, it is decay. Now again the magnetic field is being cut, so there's again change in this, so it falls down now. So it's leaving, so it falls down over here. So since it is decreasing, it is positive EMF. So positive EMF. So this is this, this is this. So this is about graph. So this is growth while the magnet is entering, and since opposing EMF, so minus E, and in this case it remains constant when it is moving inside the coil, and when it is quitting the coil, at that time again decay is happening, and flux wise it's keeping on decreasing as it is leaving the coil. And what is happening in terms of EMF is positive and increasing. Why? Because it is being cut. Lines of force are being cut over here, but since it is coming out of it, so it is positive. So I hope the graphs what we did is understood. All right.